inscribed angles and central angles. An inscribed angle has its vertex on the circle, and the relationship of the angle and the arc that is chopped out between the two lines that make the angle is that angle is equal to 1/2 the arc it bites out. So you simply read between the lines. This is the only arc that matters to this angle. And then you take half of it. So with a central angle, that's this situation right here. A central angle is made by two radii, and it has its vertex at the center of the circle. That angle is going to exactly equal the arc that it subtends or chops out. So when you read between the lines, let's say this was 80 degrees, then this angle would be 80 degrees. Every other situation we have with circles is going to have a 1/2 in the equation, and you just read between the lines. So this angle is equal to 1/2 of what's between the lines. This one's interesting because it's opening up to a diameter. A diameter cuts a circle into 180 and 180. If this is opening up to a diameter, it's opening up to 180 degrees, and 1/2 of 180 degrees is 90 degrees. This also is an inscribed angle because its angle is on the circle. So again, we have a diameter and then we're extending out. Since if I read between the lines, this is 180 degrees, it is half the circle, therefore this has to be 90 degrees. It doesn't look like the other pictures, but if I read between the lines, I still have 180 and my angle is on the circle. Example 1, angle ABC is 56 degrees. What is the measure of arc AC? So here's arc AC. And if I extend this, it's between the lines. So I have 56 degrees is equal to 1/2 of the arc. And I'll call that X. The 2 is attached by division on this side. Move it by multiplication. 2 times 56 is 112 equals X degrees. So this would be 112 degrees. It's best to start with the formula every time. The vertex is equal to 1/2 of the arc. I often write it like that because then I can fill things in. Pause the video and sketch this on your paper, try it on your own, and then come back and I'll show you the solution. Here's the solution. It's 45 degrees. I did first have to find out the measure of the arc that was between these two lines. So I took 360, my whole circle, subtracted off the 270 for this major arc, and got that minor arc QS was 90 degrees. And then half of 90 is 45. Example 2, AB and BC are radii of circle B. So that is telling me that this is a central angle. Angle ABC is 120. So this is 120 right here. That means this arc is also 120 degrees because it's a central angle, which equals the arc. What is angle ARC? Okay, go with my formula. The angle is equal to 1/2 of the arc. In this case, ARC is what I want to know, and 1/2, and then the arc was between the lines was 120 degrees. So the final answer is 60 degrees. Here's try it 2. Pause the video, do it, and then I'll show you the solution. Here's the solution to try it 2. We did the inscribed angle and the central angle. Here's try it 3. Pause the video and then come back and I'll show you the solution. Here's the solution. And when a picture gets more complicated, it's pretty neat to see that XMY is the central angle, XZY is the inscribed angle. Notice they both start with X and end with Y. X and Y. That helps me to recognize that they are opening to the same exact arc. Example 3. I is the center of circle I, and both LP and ST are diameters. So this is important. Both of these are diameters. That means this is 180 degrees. And the other side would be, and also from L around to P would be 180 degrees. Okay, angle LTS measures 25 degrees. This angle is 25. So I think I want to determine everything here. So if this angle LTS is 25, it equals 1/2 of the arc it subtends. Read between the lines. So if this is 25, bring up the 2, then I get that this arc is 50 degrees. I'm going to write it here. Okay. Then that means LIS, which is a central angle because I is the center. So angle LIS is 50 degrees because it opens to a 50-degree arc. If I look on the other side, LIT, it says this is a diameter, which means it's a straight line. So if this part is 50 degrees, then a straight line is 180 minus 50 is 130 degrees. This would be 130 degrees. And that would be this angle, LIT. I'll write it here, is 130, which is not, by the way, LTS, which we found out was inscribed. Okay, so then arc LT would be, 130 degrees. This is getting super sloppy, but it's good to see how many things you can do in a single circle. Now, if this is 50 degrees, then this has to be 50 degrees because of vertical angles. So then arc PT is 50 degrees. And I think I answered everything. Oh, wait, well, okay, how about SP over here? 180 minus 50, that's 130 degrees. All done. Just try it 4, pause the video, draw it on your paper, and try this out. Okay, here's the solution to try it 4, and this one just looked different than the other ones. It is the same exact situation. I have a central angle opening to an arc of 80 degrees, and my inscribed angle is opening to that same arc. This angle would be angle SBT, and this central angle is angle SET, and the arc is ST. So do you see how the arc is ST? This began and ended with S and T. This began and ended with S and T. So this opened to this arc. This opened to this arc. This was a central angle because it went to the center of the circle. This was an inscribed angle because it went to the actual circumference of the circle itself. And this is an arc, angle, angle. Example 5, FT is a diameter of the circle. Okay, they don't even draw it, but I can see that F to T is actually cutting the arc into 180 degrees this way, and therefore also this way. So you don't need a line to know that this is cutting it in half. What is angle FIT? So angle FIT is inscribed. It is on the line. So the angle is equal to 1/2 the arc it cuts out. The arc it cuts out is FT, and I found out FT is 180. And I could name this if I want, FIT. So I'm getting 90 degrees. It just so happens every time you're in an inscribed angle that opens up to the diameter, you are 90 degrees. And finally, TR is the diameter. What is TRY? So again, I am an inscribed angle. I am TRY. I am on the circumference, and this is going through the center of the circle. So this is 180 degrees, this arc. So between these lines is opening to 180. So angle TRY is equal to 1/2 of the arc, and I can fill that in as 180. So I'm getting 90 degrees again. These look different, but they're the same scenario. Thank you so much for being here.